This is Jacob's Algebra, Chapter 11, Lesson 8. The title of this lesson is Complex Fractions, but that has a specific meaning in math, so I really don't know why he chose the name complex fractions. He should have said more complicated fractions. So we've done a lot of work with simple fractions. Simple fractions have no fractions inside of them. A complicated fraction would be something like 1 over 2 plus 1/3. That's a complicated fraction. It has a fraction inside of it. We can learn how to actually simplify these to make these a fraction of two integers, or a fraction at least with no fractions inside of it. So what we first need to do is simplify our denominator. We have 2 plus 1/3. What is 2 plus 1/3? Well, we have a fraction we're trying to add to a whole number, so we need to put them in the same kinds of terms. So we're going to multiply the 2 by 3/3, and now we have a common denominator. 3 times 2 is 6, and then we have our 1, so this is 7/3. Or you could look at this as just a mixed number, 2 and 1/3. 2 times 3 is 6, plus 1 is 7, so that's 7/3. So this fraction is actually 1 over 7/3. And you remember from the last lesson that dividing by a fraction is the same as multiplying by its reciprocal. So we can write our numerator times the reciprocal, which is 3/7. So what we have is actually 3/7. Now, we might have a more complicated fraction than this, but we're going to go ahead and start working on some problems, and we'll look at those then. So let's start with number 4, which is just like number 7 that I assigned for homework. Part A is 1/3 divided by 5/6. Okay, remember, dividing by a fraction is the same as multiplying by its reciprocal. This is exactly the same as 1/3 divided by 5/6. The fraction bar means divided by, which means we can rewrite this as 1/3 times 6/5. So we copied our first number, our first fraction, we changed the divided to a times, and then we flipped over our second fraction, 5/6, to get 6/5. That's the reciprocal. Now we just have the product of two fractions. Anytime you have a product of fractions, you want to see what you can cancel. So the 3 and the 6 have a common factor of 3. So the 3 becomes a 1 and the 6 becomes a 2. And the answer to this fraction is 2/5. Okay, let's take a look now at part C. Part C is 10 divided by 1/2 minus 1/7. Well, we can't do anything until we simplify our denominator. What we're going to need to do is find a common denominator for this. So I'm going to multiply this first fraction by 7/7 and the second fraction by 2/2. And so we will end up with 10 over, this is going to be 7 minus 2, so that's 5, over 7 times 2 is 14. So we have 10 over 5/14. That is the same thing as 10 times 14/5. The 10 and the 5 have a common factor. 10 becomes a 2, the 5 becomes a 1, and our answer is 2 times 14 is 28. Okay, let me get a new page for this next one. Let's look at number 4, part E. We have 4 plus 2/5 over 4 minus 2/5. Okay, that's pretty complicated. So again, the first thing we need to do is simplify our denominator. In order to make this one single number, I'm going to have to make this one fraction. That means I'm going to have to find a common denominator. I have a fraction of 1 and a fraction of 5. So I'm going to multiply this first one by 5 over 5. And so what I'm going to end up with is 4 plus 2/5 over 5 times 4 is 20, minus the 2, and this is all over 5. So I end up with 4 plus 2/5 divided by, and that's 18/5. So remember, dividing by a fraction is the same thing as multiplying by its reciprocal. So I can write this as 4 plus 2/5 times 5/18. We can see our 5's will cancel each other. The 2 and the 18 have a common factor of 2. The 2 becomes a 2. The 18 becomes a 9. This is 4 1/9. And we can leave it in that form, or you can change it to an improper fraction. 4 times 9 is 36, plus 1 is 37, and we have 37/9. Either one of these would be okay with me. If you end up with a mixed number as your answer, that's fine. Or you can simplify it to an improper fraction. Okay, so that was number 4, which is just like number 7. Let's look now at number 5. Number 5 says simplify. So let's look first at part A. We have x plus 2 over 3 divided by x plus 3 over 2. Well, this is a simple problem of dividing with fractions. So I'm going to copy my first fraction, which is the numerator, x plus 2 over 3. Change the divided by, that's the fraction bar, to a times. And I'm going to flip over my bottom fraction, the denominator, 2 over x plus 3. Okay, you can see here that nothing is going to cancel. So my answer is going to be 2 times x plus 2 over 3 times x plus 3. And you can leave your answer in this factored form, or you can multiply it out. If you multiply it out, it's 2x plus 4 over 3x plus 9. Okay, let's take a look at another part. Let's look at 5c. 5c is 1 plus 1 over x divided by 1 minus 1 over x squared. Okay, I need to get common denominator in the numerator and a common denominator in the denominator. So in the numerator, I'm going to multiply this first number by x over x. And in the denominator, I'm going to multiply this by x squared over x squared. So in the numerator, I'm going to end up with a common denominator of x, and I will have x plus 1 in my numerator. The denominator, I'm going to have a denominator of x squared, and I'm going to have x squared minus 1. Now we have a simple case of dividing a fraction by a fraction. So we're going to copy our numerator, which is x plus 1 over x, change this fraction bar to a times, flip over the denominator so that we have x squared over x squared minus 1. Now it's easy to see that our x and our x squared have an x in common. So our x becomes just a 1 and our x squared becomes an x. But there's something more that we can do, because this x squared minus 1 can be factored. So let me just write down what we have so far. We have x times x plus 1 in our numerator. In our denominator, we have x squared minus 1. That x squared minus 1 can be factored. This is a difference of two squares, x squared minus 1 squared. So I'm going to write that out in factored form, x plus 1, x minus 1. You need to get to where you can recognize the difference of two squares. Anytime you're taking the difference of two numbers and both of them are squares, that means that you can factor that as the difference of, as the first term plus the second term multiplied by the first term minus the second term. Whatever thing you're squaring. So you can see our x plus 1's cancel, and we end up with x over x minus 1. Be sure that you recognize anytime you see a squared minus b squared, that can factor as a plus b times a minus b. This is crucial because you're going to see this all the time. If you see 4x squared minus 16, you should be able to see that first you can pull a 4 out. 4 times x squared minus 4. And then x squared is the square of x. 4 is the square of 2. So this would be 4 times x plus 2 times x minus 2. You've got to be able to recognize the difference of two squares when you see it and immediately know how to factor it. Okay, let's move on and look at 5e. 5e is 7 over x minus 1 divided by 1 minus x over 7. Again, we need to get common denominators in the numerator and in the denominator. So in our numerator, we have a fraction over x, and then we have 1. So I'm going to multiply the 1 by x over x. In the denominator, I'm going to multiply the 1 by 7 over 7. So in the top of our fraction, we're going to have 7 minus x over x because we have the 7 and then we multiply this 1 by an x. In the denominator, we're going to have 7 minus x over 7. Now we have one fraction being divided by another. So we copy our numerator, 7 minus x over x, change the fraction bar to a times. We flip our denominator, 7 over 7 minus x. We can see the 7 minus x cancels, and what we end up with is just 7 over x. Okay, let's look at part F. I'll just put that down here. Number 5, part F, we have 1/4 plus 1 over x divided by x squared minus 16. Okay, so let's first fix our numerator and make that one fraction. So I'm going to multiply the 1/4 by x over x. I'm going to multiply the 1 over x by 4 over 4. So our numerator becomes x plus 4 over 4x. Our denominator is x squared minus 16. I'm going to go ahead and factor that to x plus 4, x minus 4. And then it may not look like we have two fractions that are being divided, but we can look at this denominator as being a fraction over 1. And so this is like, we write down our numerator, x plus 4 over 4x, change our fraction bar to a times, and we write our denominator flipped, 1 over x plus 4 times x minus 4. And now you can see the x plus 4's cancel, and what we end up with is 1 over 4x times x minus 4. And you can leave your answer in this form. You don't have to multiply it out. If you do, it's 1 over 4x squared minus 16x. But you don't have to multiply it out. I'm fine with leaving it in factored form. Okay, let's do one more part from number 5. Let's look at part H. Part H, we have 1 over x minus 7 over x squared plus 6 over x cubed, and this is all over 1 over x minus 4 over x squared plus 3 over x cubed. Now when I look at this, I see there's one way that I can get rid of all of my fractions inside very quickly. If I multiply this entire thing by x cubed over x cubed, x cubed times 1 over x is x squared. X cubed times negative 7 over x squared is negative 7x. X cubed times 6 over x cubed is 6. Now I can work on the denominator. X cubed times 1 over x is x squared. X cubed times negative 4 over x squared is negative 4x. X cubed times 3 over x cubed is a 3. We're not done though. Now we have to factor the numerator and factor the denominator. If you need to, go ahead and draw a grid to work these out. Do whatever you need to do to be able to factor these. Grids, I think grids are the easiest way to factor. If you aren't to a point where you can just see what the answers are, and usually it takes getting to algebra 2 before you can really just see what the answers are. I find the visual representation of a grid to be much easier in terms of figuring out your answers. So first we'll factor the numerator, x squared minus 7x plus 6. So we have an x squared here and a 6 there. How do we get x squared? Well, that's x times x. For our 6, we can get that either with 1 times 6 or with 2 times 3. Can we add 1 and 6 together to get a 7? Yes. So we're going to need a 1 and a 6 here. And they both need to be negative because they need to add to a negative 7x and multiply to a positive 6. So we have negative x here, negative 6x there. This makes x squared minus 7x plus 6. It does work out to what we have, so we know that it's done properly. So our numerator is going to be x minus 1 times x minus 6. Our denominator, we have x squared and we have 3. We make our x squared with x times x. The 3 is obviously 3 and 1. It has to be negative because this is negative and that's positive. So we have a negative 3x and we have a negative x. So this factors as x minus 3 times x minus 1. Our x minus 1's cancel. We have x minus 6 over x minus 3.